Hello students, good morning to all of you. Students, in the previous lecture we learned about the Newton's first law of motion and the second law of motion. And in previous lecture we learned about the impulse and time integrated effect of force on a body. And we also discussed about uh, impulse momentum theorem. Students, as the Newton first law gives the definition of force and the second law gives the quantitative idea or formula of force, that is force is defined as or represent as the product of mass and acceleration gained by the body in application of force. In today's lecture, we will learn about the third law of motion, and for discussing or understood about the third law of motion, first we will take an example or a demonstration related to the situations of Newton third law. Suppose we have a table, okay. Suppose it is first object, and a book is placed over the surface of this table, or an object of mass m, okay. This is as second object, okay. So when the body of mass m placed over the surface of the table, then the table applied a force on the body which is placed over it is known as the action force, which is applied by the table, we called force F1, okay, or force F21. And as a reaction, the body is applied a force equal to its weight. F12 is equal to its weight, which is given by mg, okay. So as in equilibrium, two forces are equal and opposite, and we say the force of first object table applied on the body is force on second object exerted by the first body, and the force exerted by the second object on the first object. So here force exert by first object on the second is called action, and force exert by second object on the first is called reaction. Okay, then according to this situation, it is very clear that the force always appears in pairs by these two. The force always appears in pairs and action or reaction force acts on different objects. So the Newton's third law is very clearly stated that according to Newton's third law, that to every reaction or to every action there is equal and opposite reaction and the action and reaction act on different objects. This is according to Newton's third law, and the situation about the first and second object may be any body or any object stated as first or second. To understand about the statement of the third law, if अगर हम दो स्प्रिंग्स को ले लें और दोनों ही स्प्रिंग को विद द हेल्प ऑफ हुक किसी बैलेंस से ऐड कर लें, तो अगर हम किसी भी एक स्प्रिंग को, सपोज कि ये हमारे पास दो स्प्रिंग है जो कि हुक की हेल्प से किसी बैलेंस से जुड़ी हुई है, इस तरह से इस वाले को हम स्प्रिंग 1 के लेते हैं और इसको स्प्रिंग 2, और ये हमारा बैलेंस है जो कि मेजरमेंट रिप्रेजेंट करेगा कि कितना हुआ। अगर हम फोर्स लगाते हैं F पर और भी से F1 स्प्रिंग 1 पे, तो हम ऐसा देखते हैं कि जो बैलेंस में वेट दिखता है वो लगभग एक जैसा ही दिखाती है दोनों स्प्रिंग्स। इसको थोड़ा सा और क्लियर कर लेते हैं। यहां पे हमने एक हुक को अप्लाई कर दिया, विद द हेल्प ऑफ हुक एक दूसरा बैलेंस लिया हमने और इस सेकंड बैलेंस को हमने एक दूसरी स्प्रिंग से ऐड कर लिया. दिस इज योर सेकंड स्प्रिंग. When we applied a force on first spring, we observed that the balance gives the same unit, suppose 2 Newton, and here also 2 Newton. And if we applied the force on the second, that is, if we stretch second spring, we observe the second spring is due to the stretching of second spring, balance gives the reading 3 Newton, and this is also 3 Newton. So we understood by this simple example that the force applied on the first is equal to the force experienced by the second, and force applied by second is equal to the force experienced by the first. For proving this, hence first we use, let two objects, two bodies A and B. So if A B is force FAB is force on A by body B, and FBA is force on B by body A. Therefore, according to third law, force AB is equal to minus force BA. This is the formula for Newton third law. Now for proving it, proof. Let an isolated system of two bodies A and B. Okay. A and B moving along the same straight line. Same straight line. Now let we allow the body collides. So let them collides collide. Therefore, let change in momentum in body A is del PA and change in momentum of body B is del PB. Therefore, according to law of conservation of momentum, total momentum remains constant after collision. Therefore, del PA equal to del PA plus del PB is equal to 0. Then we get from here del PA equal to minus del PB. Okay. Therefore, from this del PA equal to minus del PB by taking limit del T for time interval del T tends to 0. Therefore, del T limit del T tends to 0, del PA upon del T is equal to minus limit del T tends to 0, del PB equal to del T. Therefore, we find from this del PA upon del T is equal to minus del PB upon del T. Now, according to Newton's second law of motion, rate of change of momentum is force or is equal to force. That is F is equal to del P upon del T. Therefore ये आपका फर्स्ट है, this one is second. From equation second we get a relation FA is equal to minus FB. This is proof of third law. Okay. Okay, some examples related to the third law is one is the recoiling of gun. When a bullet is fired from a gun, the forward acceleration gives the backward motion in the gun or is termed as recoiling of gun. ठीक है. On okay students, next topic is principle of conservation of linear momentum. Okay, according to this principle, in an isolated system, the vector sum of linear momenta of every individual particles of system not affected by their mutual actions and reaction. That is the linear momentum of an isolated system is conserve. Okay. This principle principle is this principle is an important consequence of Newton's second and third law of motion. For proving this situation, let an isolated system of two bodies A and B with initial momentum PA and PB. Let them collide. For let them collide. Now, after an interval of time, del t, bodies A and B moving with different velocities hence there change in momentum after collision B P dash A and P dash B. Therefore force into del T is equal to change in linear momentum momentum of body A, that P dash A minus PA. Similarly, we say FA. Now, FB into del T. At the time of collision, the force act on body A due to B is FA, and force act on body B at the time of collision by body A is FB. Then it changes a momentum, or we say change in momentum of body B is P dash B minus PB. This we have two situations, और हम ऐसा भी लिख सकते हैं PAB और PBA. Clear? Therefore, this we get according to here, according to Newton's second law. Now, according to Newton's थर्ड लॉ. स्टूडेंट, हम ऐसा भी कर सकते हैं, फोर्स F AB इज इक्वल टू माइनस फोर्स F BA. ये हमारी सिचुएशन है, और हम इस डेल टी को डिनोमिनेटर पे यूज कर सकते हैं. तो हमारे पास आ जाएगा P डैश A माइनस PA अपॉन डेल टी इज इक्वल टू P डैश B माइनस PB इक्वल टू डेल टी. यहाँ डेल टी से डेल टी को कैंसिल कर लेंगे, तो हमारे पास आएगा P डैश A माइनस PA is equal to P dash B minus PB. Okay. And here minus, because minus is in the function, by multiplying P dash A minus PA in bracket minus P dash B plus PB. Therefore, P dash A plus P dash B equal to PA plus PB. That is, the change in momentum, the sum of change in momentum of body A and B is equal to the initial momentum PA and PB. This is the proof of conservation of linear momentum. conservation of linear momentum. सो स्टूडेंट्स, आज हम यहीं तक कर रहे हैं। कल हम इससे आगे चलेंगे और न्यूटन्स लॉ ऑफ मोशन की एप्लीकेशन को कैसे सॉल्व करना है उसको सीखेंगे। थैंक यू।